Okay, so welcome to my talk. My name's James Roper. I work for TypeSafe as the tech lead on Play Framework. And this talk today is called All Work, No Play Doesn't Scale. Now, when I talk about scaling here, often you think of scaling in terms of performance. That's not the only way that things might scale. Scaling can cover lots of things, and specifically what I'm talking about is scaling in terms of development productivity. So how can you scale the writing of apps quickly and maintainable apps? So yeah, this is going to be an introduction to Play Framework. So can I get, I suspect there probably are a number of people here who are already using Play Framework, but are there anybody here that have never used Play Framework or consider themselves new to Play Framework? Okay, good number. So yeah, this talk is aimed at you. Those of you who just put up their hand, have you done, is there anybody that hasn't done web development before? Okay, that's good. So I'm assuming that you understand a lot about web development, but yeah, you haven't used Play before and you want to get an idea for how to do things in Play. So now, I don't like doing a lot of work. That's why I called this All Work, No Play Doesn't Scale. And I like coding, and to me, writing slides is just work. So let's go on to my last slide. What is Play Framework? So Play Framework is a Java or Scala framework. It has both a Java API and a Scala API. So you can use the Java API, you can use the Scala API, you can actually use them both together. There's no reason why you can't do that. Today we're just going to be looking at the Scala API. It supports fast development loops. So when you make a change in Play, the moment you hit refresh in the browser, you'll see that change. It might take a little while to compile, but you'll see that change. It supports asynchronous I/O, and this is not just a bolt-on thing like the servlet spec. It's asynchronous I/O from the ground up. It's first-class support. Everything that you do is asynchronous. It has first-class support for the modern web. Now, what do I mean when I say the modern web? Well, first of all, the modern kind of standards like WebSockets and server-sent events, these are really first-class things in the framework. Less CoffeeScript, requireJS, a lot of your front-end technologies Play has support out of the box for, or can make integrating very, very easy. So you don't need to worry about having to set up your build scripts and do all this complex stuff and make sure that stuff's working when you're in your development loop. Play supports that for you. And also JSON is a first-class technology. I think it's important to note that a lot of the stuff that we do these days is in JSON, and using JSON in Play is as natural as using forms or HTML or anything else. So with my last slide done, we're going to get onto a live coding demo. So what I'm going to do here is I'm going to create a new application. It's going to be called Feedback, because it's going to be a simple application for simply leaving and creating feedback and viewing feedback. Kind of like, a feedback on a survey or for something, how things have been done. So I've just created the new application. I ran Play New Feedback. I said I wanted a Scala application, and now it's going to put me into the Play console. So the first thing I'll do is I'm going to create an IDEA project for that, because the IDE that I'm going to be using is IntelliJ. And IntelliJ wants me to update. Okay, so that's done, and now I'm going to run it. So let's go and view it in a browser. And while I'm doing that, I'm also going to open it up in IDEA. So you can see here I have the application running in a browser already. By default, it brings up this kind of welcome page, which gives you information about Play. There's some links to the documentation. Those links are all served locally, so you can go and learn play on a plane if you want. This is the same documentation that you find on the website. It's all there, and that's all served locally. So, but we're not interested so much in the documentation because I'm giving a presentation here. Let's find out what it looks like. How does play serve this initial page here? So the entry point to a play application is something called the routes file, and if you've done any Ruby on Rails development, this will be fairly familiar to you. So this is the routes file. We've got a number of routes defined. The first one is our index page. So when you go to the slash URL, it's going to, with a GET request, it's going to invoke this controller. Now we call this an action. It's the index method on this controller, and you can see here that all our action does is it returns OK and renders a view. So before we make any changes to this, let's see what happens. We've got another controller here. This is how we serve assets, so JavaScript and CSS and images. Now, what's something to note about this controller, about the routes file, is that it's completely type safe. So for example, I'm saying that the path is the string public, but what if I pass 1 into there? Well, if I hit refresh, you'll see here that it actually doesn't compile. You get a nice error message. It shows you what line it's on, and it says a string is required, but you've passed in an integer. So we can see we've got type-safe routing here. So back to the controller. Maybe we might put a compile error in the controller. So for example, I'll misspell action. And again, if we hit refresh, we can see immediately that play tells us what that compile error is, where the problem is. You can't find this thing called action with an E on the end. And here we have our template. Now, a template in Play, you can implement your templates using anything, but what comes out of the box is something called Scala templates, and these are type-safe templates using a syntax that anything after an at is roughly equates to a snippet of Scala. So we have, this is the parameter, this first line is the parameter declaration. It says this template takes a string. You'll see that's strongly typed, so here we're passing in a string to it. If I were to change that to a number, that would be a compile error again. So you can see it's very strongly typed. So I'll change that back to a string. And you can see here we are invoking another template, the main template. These both, by the way, are both defined here. And so I can go to the main template, and you can see the main template accepts a title and another parameter called the content, which is an embedded HTML block, and it renders that content here inside the body. And so the content that we're passing is this welcome page. Okay, so let's start doing our application. So the first thing that I'm going to do is I'm going to change this body just a little bit to put in a title and to include some content there. By the way, you'll see a lot of shortcuts with code appearing. This is IntelliJ live templates. It's not all just IntelliJ magically knowing what I'm doing. So I'm going to get rid of the default welcome message, and I'm going to put in a header there, which is an internationalization key. So having made changes to our template, we can hit refresh, and we can see it's now rendering my page with this feedback title. So this is a feedback application, and what we want to do is we want to submit some feedback and store that feedback somehow. So we need some class to model the feedback. So we'll create a class called feedback. So I'm going to create it. By convention, we put it in a package called models. It doesn't have to be in a package called models, that's just the convention. I'll make it a case class. and I'm going to put in some parameters there, username and feedback. So feedback consists of a username, the person who left the feedback, and the feedback itself, and they're both strings. So now we want to create a form for handling that feedback. So to do that, we'll go to our controller. I'm going to start off here by adding some imports that we'll need for later in the presentation. And then I'm going to declare my form. So this is a form. It says how parameters coming in a request should be bound to our feedback object. So you can see we're saying we're defining some mappings. A parameter called username should be non-empty text. So this is validation here. Play comes with a lot of validators out of the box. For example, you can say that it's an email, you could say that it should be a number within a certain range. You can define your own validations. We're just doing the simple non-empty text. Same with feedback, it should be non-empty text. And then we're binding that to the feedback apply and unapply methods that are generated by the case class. And this allows us to convert the parameters that come in from the request to a feedback case class instance. Now, before we actually receive the request, we want to write a page that renders the form so that you can then fill it out and submit it. And so this object is not just used for binding the parameters, it's also used for declaring the actual page, the actual form. So when we, in our index form page, we're going to pass this form so that it can be rendered. Now, of course, index accepts a string, not a feedback form. So we'll change that to accept a feedback form. And now we can, we're going to add some, can I get some water actually? Okay, so now we're going to specify some imports. So for rendering forms, when Play provides some helper methods for rendering forms, and we'll see those right now. So we can see here we've defined a heading, and then this input text is part of the helpers. It's saying render a text field based on the username feedback parameter, and another text field for the feedback one. You can use render password fields, and you can render option fields and all sorts of things. And then we've just defined a submit button. And the form currently doesn't do anything. We'll worry about that later. But let's see what happens now when we hit refresh and see if it renders. Okay, so we can see that we've got our feedback form. It doesn't do much yet, and we've got all these internationalization keys. Let's make that a little prettier by defining those keys. So we're going to create a messages file. You can create messages in lots of different languages, but we're just going to worry about one for today. And so having created that, if we hit refresh, now that's all nice and at least localized to English. Okay, now we want to now submit the form. So we're going to write another action. We've got our index action. We're going to write another one called leave feedback. So the difference you can see with this action, we're actually defining that it accepts a request. Because we want to get the body out of the request to get the feedback parameters, we say that it accepts a request. Of course, our index one can also accept a request Doesn't need to do anything with it yet, but it will later. So the next thing we want to do is we want to bind our incoming form. So you can see this line here, I'm calling bind from request. Because the request is implicit and bind from request accepts an implicit request, it doesn't need to be explicitly passed there, but it is passed. And then we're folding it. So with fold you pass in two callbacks. One is what happens when there is an error in binding the form. So if the validation fails, or if the types don't meet up, or if something's missing, then this callback will be executed. And in this case, we're just rendering the index with the form that failed validation, and that will actually contain our error messages. And then the second callback is what happens when it does successfully bind. Now, we're not going to worry about saving it to a database just yet, but what we want to do is when you post a form, the best practice is to redirect to a page. So we're going to redirect. And now we can see a feature of Play called the reverse router. And so what I'm doing here is I'm passing in the index reverse route. So this routes file is not just compiled to something that does routing, it's also compiled to a set of interfaces that can create URLs based on what you pass into it. And so this means you don't need to embed all these URL strings, especially if you've got parameters in those URLs. You don't need to worry about string building when you're doing redirection or when you're referencing it from templates. So here we have that redirect, and then we also we want to give the user some indication that something's happened. Yeah. Oh, sorry. We want to give the user some indication that something's happened. So we're going to use something called the flash scope. Now the flash scope is a cookie that's sent back to the browser that will be cleared on the next request, but we can access it on the next request. So it's great for sending after redirecting where you've lost the state to send a message like you successfully submitted the feedback and I successfully saved it. So we're going to send this flash scope, and then we're going to actually read that from the index action. We're going to look up that status message from the flash scope. So we've done the action side of things, but in our form, we need to say that we accept this message, which is going to be an option. So we've got status is an option of the string with default of none, and we also want to render that, of course. And now we want to go and define the route for our leave feedback action. So we're going to, if somebody does a post on slash, then we want to invoke leave feedback. Now, again using the reverse router, we want to, for some reason IntelliJ isn't auto-completing like it used to. We want to use the reverse router to refer to our action that we just created. So the leave feedback will be part of the reverse router, and we're saying we want a form that will submit to that. Now you notice here that we don't actually have to define the method because that comes from the reverse router, and the URL that we're submitting to also comes from the reverse router. So let's see if that renders now. Okay, so now if I hit send, I'll get these error message saying this field is required, and I can submit something and it says feedback left by J. Roper. But we're not actually doing anything with it yet. But before we do that, let's make the application look a little prettier. So Play in its default template gives you a main.css for defining style sheet for your style sheet. What we're actually going to do, I don't want to use CSS, so I'm going to delete that. And I'm going to create a new file called main.less, because I want to use less just because I can. So I'm not going to bore you with writing less style sheets, but you can see that I've put some less in there, and let's see if it gets compiled. And now it's styled. So I didn't have to really do anything there to get less working other than create the file. It just works out of the box. And we can see some pretty stuff there. And it's all looking pretty. But our application doesn't actually do anything yet. So let's do something about that. So we want to store to a database. The first thing we want to do is tell Play how to connect to a database. We want to say what database to connect to. For this presentation, I'm going to use an in-memory database called H2. And so this configuration says that the database called default is going to be an H2 database, and that's the URL. I also want to define a schema for this database. And Play has a feature called evolutions. So I'm going to create an evolution. And this defines the schema. So we can see here there's some ups, and these are the things that are run when the evolution gets applied. And so this is going to create a feedback table with an ID, username, feedback. And then there's some downs, and this is how to roll back the evolution if it needs to be rolled back. Now when I hit refresh on my application, we get this error message saying that our database needs an evolution. So it's connected to the database, but it's found that this evolution for creating the feedback table hasn't been applied. So we're going to tell it to apply that. So now we have our schema set up. Let's look next at actually talking to the database. So we've got our feedback class here. I'm going to add some imports. The way we're going to be talking to the database is using an object relational mapper. Well, it's not really a relational mapper, but it's called anorm, and it is, I guess, JDBC on steroids. It makes it very easy to bind classes to and from JDBC result sets. So the first thing we'll do is define an insert method. So you can see here we have a statement, and we're going to bind, we have declared two variables in this statement, username and feedback. We bind them to the username and feedback variables from our case class, and then we execute insert. And that takes an implicit connection. Now one thing with the pattern that I'm using here, where I'm putting the method directly on the object, you don't have to do that. You can put it in a DAO if you want. But since we're passing connections around implicitly, it's not really that difficult to. It doesn't really make our object live since you pass in the stuff that is live. So it's not really that bad to put your methods on the case class. So now using this, when we post some feedback, we want to call that method. Now it takes an implicit connection, so where are we going to get that connection from? Play provides a helper called db.withConnection, and it gives you an implicit connection in scope, and so that's going to be used when we call our insert method. So now let's have a look and see if that works. And give it a few moments, and it looks like it probably did work, but of course we don't know yet because we haven't written anything to see what's in the database. So the next thing we'll write is a method for retrieving feedback from the database. So I'm going to do this in a companion object of feedback. So I'm calling the method findAll. And the first thing we have here is our statement. And then here we're defining a row parser. And what it's saying is that there should be a column called username and a column called feedback. They're both strings. And we apply this over and over to each row. The star is kind of like a star in regular expressions. Then we map our row parser. The flattening turns the output of the row parser into a tuple, which we can then apply to the feedback .apply method, and so hydrate our feedback objects. And then this actually doesn't get executed until we call this take method, which says take 10 results. You could also just convert it to a list to get all the results, but we're just going to get 10 here. So now we've got our findAll method. Let's invoke it from application. So we're invoking it in our index action, and of course because it takes an implicit parameter of connection, we need to wrap that with a db.withConnection. And we'll also call it in our leave feedback when we get an error, because the index page will need it there. So now we need to update our template to accept and render the feedback. So we've said that our template now accepts a parameter called allFeedback, which is a type of sequence of feedback, and we can render that here. This is using a for loop as part of the Scala template syntax, and it's just simply iterating through all the feedback and rendering it. And you can see how easily we can just refer to Scala properties. So now hitting refresh. Oh, hang on. You can see there's that feedback that I earlier submitted. Okay, so now we have a very basic feedback application using forms, which is, I guess, an old way of doing things in the web. Websites these days tend to be a lot more dynamic, so let's start adding some dynamic features and seeing what that looks like in our application. So the first thing that I'm going to do, has anybody here heard of Clout before? Okay, so Clout is a service that goes and takes all your activity on social networks and looks at how much influence you have. And it ends up giving you a score. You can see my score here is 58 of how influential you are. So we're going to use this Clout service to look up and find out how influential each person that left feedback is. So just as a side point, Clout actually uses Play2 as to implement its API. So we're actually writing a Play2 app that's talking to another Play2 app here. So to start off, I need a Clout key. I don't want to tell you what that is, but it's a string. And the next thing that I need is an action for looking up a user's influence. Now I'm actually using a few new things here. So first of all, you can see this action takes a parameter called the username, and this we're actually going to get out of the URL in the routes file, and you'll see how we do that later. The other thing that I'm doing is I'm using some action composition here. So I'm using this thing called cached, and this is going to cache the response for 120 seconds, and that's going to ensure that I don't hammer Clout all the time. And then I've got my normal action declaration in here. So this is going to be a web service call, and Play provides a web service client, and when it makes a request, it doesn't return it immediately. It does it asynchronously. So what it actually returns is a future of a response, not an immediate response. So we're going to return a future of a result. So the result is the result of the action, and our action returns, so that'll be eventually okay. But for now it's just this future that we don't know what it's going to be yet. So using the Play web service client, it's called WS, we pass it a URL. So the first thing we want to look up is we want to look up the user's identity based on their Twitter username. So we'll pass in some query parameters to that. So their screen name, which is the username, and the clout key is another parameter. And then we call get on that. Now you can see here get returns a future of a response, and we want a future of a result. So we can't use this immediately. Instead we're going to have to map it. But before we map it, we actually want to flat map it to do another call. So flat map is equivalent to saying do this and then do another asynchronous thing. So we're calling Flatmap, and then we're going to first make sure that the result was successful. If it's not successful, then we're just going to immediately return a successful future saying the score was 0. But if it was successful, then we want to extract the ID of the user from the response and then make another call to actually look up their score. And so here we have the future of the second response. And so before we return that, we want to map it to be a result. So we're just going to pass the JSON back as it is, as our result. So we've got our action for looking up a user's influence. Let's now go to the routes file and define the route for that. And this is where you can see this username parameter is used. We define our URL to be parameterized with a username, and we pass it into the influence method. Sorry. Okay, so now to use this, we're going to write some CoffeeScript. I could write this in JavaScript, but just because I can, I'm going to use CoffeeScript. And so I've got some CoffeeScript here that goes and finds all the status updates on a page and the usernames of those users, and goes and looks up the influence, calling our influence action. And then I'm going to call that when the window is ready. So this is just an AJAX call here, using jQuery, get JSON, passing in that URL. And let's have a look at, see if this works. Something I didn't do was include the JavaScript on the page. And you can see there my score is coming up. So we'll try for another user. Nobody doesn't like this presentation. And we can see here that nobody has a higher score than I do. So let's. So now we've got some JavaScript happening. You can see how CoffeeScript works, and you can see how asynchronous web service calls work. Why don't we try something really advanced like WebSockets? WebSockets is really quite an advanced thing for most web frameworks. You have to go into low-level APIs and things like that. How does Play handle it? Okay, so the first thing we're going to do is a WebSocket is a stream that comes a full duplex stream to and from the client. So we need something that produces things to send to the client and something that consumes things from the client. And Play uses a concept called iteratees for these consumers and producers. So to do this, we're going to use a broadcast enumeratee that all clients will share. So this is an enumerator. So this is the enumerator. It's the producer of messages to send to clients. And then there's this channel, and the channel can be used to push messages into the broadcast enumerator. We've also declared a rights for feedback. This says how to serialize feedback into JSON. This is actually a JSON macro, and it allows us to generate something that is at compile time verified to generate JSON. So then we write our WebSocket action. So instead of declaring it to be an action, we declare it to be a WebSocket that talks JSON. And here's our consumer. Now this is using a for each iteratee, so imperative style, and it's doing nothing. It's just returning unit. And then we have our producer, which is the broadcast enumeratee. We'll do something later, but for now we're just going to push data to the client. So when a user leaves feedback, we want to push into that channel. So we serialize our feedback to JSON. Okay, so how do we use this from the JavaScript? Well, first we need to define a route for it. And defining a route just looks like any other route for a WebSocket. We're just going to call get on feed and invoke the WebSocket. And then in the CoffeeScript, we will create a WebSocket first, define an onMessage handler, so that will parse the event and then add the new message, the new feedback to the screen. And that's all we need for now. So I'll hit refresh here. And now in another window, I'm going to visit the application. And let's see what happens. So you can see I just submitted some feedback, and immediately in this window that feedback appeared. So our WebSocket is now pushing dynamically to our application. What if we want to receive data in the other way? So instead of using a form post, we're going to post via the WebSocket. This is very easy to do in the Scala side. So instead of doing nothing for each message, we're going to bind, using our feedback form, binds the JSON. Now this is a great thing about the form API is it can be reused to parse JSON and to validate JSON. And if it doesn't have any errors, then we're going to insert and push to our channel. So now in the CoffeeScript side, we want to hijack the submission of the form. So when somebody clicks submit on the form, we're going to send that through the WebSocket. So now, refreshing on our screens, you can see that there was no page refresh there, it just submitted directly via the WebSocket. Okay, so what have we seen? We've seen how Play lets you, first of all, scale using very high development productivity. The moment you make a change, when you switch back to your browser, you hit refresh and it works. If it doesn't work, it gives you a nice compile error that you can see and quickly work out what's gone wrong. We've also seen how Play supports the modern web. It's got first-class support. These things are baked into it. asynchronous I/O is baked into it. It's just as natural doing asynchronous I/O in Play as it is doing synchronous I/O. In fact, it's more natural doing asynchronous I/O because you don't need to worry about thread pools. So Play is the web application framework that lets you scale your development productivity. If you have any questions, or if you want to follow me on Twitter, you can. My Twitter handle's there at jroper, or talk to me later. I can take a few questions now, I think. Anybody got any questions? Yep.
Is the source code you just showed us available?
Yes, it's available on GitHub. The URL, I think, is. I'll look that up while I take the next question. Anyone else got questions? Yep.
I mean, is CoffeeScript or is CoffeeScript like the default supported language for JavaScript?
CoffeeScript support comes out of the box. There are many third-party plugins for enabling support for other things. I know there's somebody actively working on Dash at the moment. Any other? Yep.
Is there a performance difference between the Java version and the Scala version?
Is there
Performance difference?
So there is, in raw performance of requests per second, in some trivial benchmarks, the Scala comes up faster. But as far as scalability, something to note about that is that the time spent in application code, typically in a web framework, is very small compared to, say, going to the database. Both will scale horizontally, which is really the important thing. Just whether something can handle 10,000 or 20,000 requests per second is a little irrelevant if as long as both of them you can add more machines and get linear performance. Yep.
How does Play work with other enterprise applications? So if you have a logic portal, can I embed a Play app?
So there is a third-party WAR plugin for Play. However, we view Play more as a container. So would you deploy JBoss to WebLogic? The answer is no, because they're both containers, and Play is a container too, so you wouldn't deploy it to another container. So it is the runtime for running your application. So it's the complete solution, the complete stack. Yep.
You could also, we've done this a little bit of work, you can have Play be used to backend support load or something like that.
Yep.
For digital channel.
Yep. Anyone else? Okay, well, thanks for coming to my presentation.